Okay, so after this longer introduction, this section is going to be really short because you already learned all the basic technology behind search-based bot. So the idea in a search-based bot is that you already have a large number of question and answer conversations. For example, if you go to an e-commerce website like Amazon, there are these Q&A pairs for every product, which they crowdsource. So for example, one user asks, I have an Echo Dot in my house. Can I use this on another Wi-Fi system? And then there is an answer coming from any other user, plus various other answers corresponding to this question. And you'll see you can actually download a data set that someone curated with 1.4 million answered questions from this website here. So now the idea is somebody asks a question into a bot that is similar to maybe this one here. Well, it doesn't have to be the exact wording, but it's similar enough. And now you just learned in the previous weeks that one way of finding out the similarity is to use the idea of vector space model. So what we would do is we look at the new question that someone types in. We create a TF-IDF vector, and then we compute the cosine similarity of the question with all the other questions that we have in our database. And then you just pick the answer that is closest to the question that corresponds to the question that was closest to the incoming question. Essentially, there are two variations. If you have a database of only the answers, then you would do a comparison of the question with the answer, where you assume that the answer has somewhat the information embedded that was asked in the question. Or in the better case, when you have both question and answers in a pair like here, then you do it like I just explained. There are some other techniques that some of them we'll learn a bit later. There's not just TF-IDF vectors, there are also other ways of vectorizing information, but this is one fundamental basic technique that you can also experiment with in the lab. And based on these techniques, there are lots of bots online. So again, remember this huge list of online services I showed you. So many of those fall into the category of enabling these question-answer pairs. And one example is Q&A Maker from Microsoft as a cloud service. So here, you already have content. You have support information, question and answers that people asked about your products, possibly already curated in FAQ pages or any other kind of document. And then you just feed them into a nice web interface. And then the system will make you a bot for it. So this is, again, there is another trend online, this no-code development, no coding. You basically write a bot, but you don't write a single line of code. You just support the content, set a few parameters, and then you get a bot developed for you using the website. So of course, Q&A Maker, and I'll talk about some other cloud techniques later, also integrates other techniques, but this is one of the core idea behind this no-code development of a Q&A bot. And then it has various other tools for analyzing the bots. Once you have it running on the cloud, you can see which answers came up. Possibly users can interact and say good answer, bad answer, and therefore improve the bot over time. So that's a simple but still powerful technique of developing a bot if you have a knowledge base in the right format. If you have a lot of documents, a lot of content, possibly from an online forum or that you manually curated, or from a bug tracking system, a ticketing system, then you can easily convert this into an online chatbot. And that's already it. So again, all the theory behind it, vectorization, TF-IDF, cosine similarity, all of this you have learned previously. And here you just had to see how to connect this with the development of a question answer bot. And in the next part, I'll talk about the pattern matching bots. See you then.